Hey Paige, this is from the homework. You asked about homework 109 and then 115. So I'm going to go over 109 right now. But if you figured it out, because we did talk about it a little bit in class today, then fast forward until you see 115. But so it says, determine whether each of the following scenarios describes a geometric setting. If so, define an appropriate geometric random variable. So 109A, we have cereal, and then each cereal box has some cards in it. And there's a 1 out of 5 chance, so we have our probability. Anyway, so if you're looking at 109A, it says that we're going to buy boxes of cereal until we have all 5 drivers' cards. Now, geometric is binary to begin with. So it has to be binary where there's 2 options, a success and a failure. It has to be independent, and then we're going to have trials until we're successful. Now, 109A, it's not binary, so it fails there because there were 5 cards we could get, and so there are 5 options, so it fails on the binary, so we don't even need to go on to independent, trials until we're successful, or same probability of success. All right, B says, in a game of 4-spot Keto, Lola picks 4 numbers from 1 to 80. The casino randomly selects 20 winning numbers from 1 to 80. Lola wins money if she picks 2 or more of the winning numbers. The probability that this happens is 0.259. Lola decides to keep playing games of 4-spot Keto until she wins some money. So first we're going to look if it's binary, and it looks like it is, because she's going to pick 4 numbers, and so she either wins or she loses, right? So she wins money or she takes the L, okay? I is it independent? She's just randomly picking these numbers, and they're randomly picking numbers, so I think that we're good there, all right? So meaning that knowing that one event has happened is not going to change the event of the next. So remember, independence there. But I think we're good. I believe we're good. And so then the next thing is, are we going to do trials until we're successful? And it seems like we are, because it says she's going to just stick around and keep playing until she's done, right? So she's doing trials until she's successful. And then it does say our probability is the same. So it looks like we're good. So we checked out on all of those, same probability. So it's a geometric random variable, and I think that's all we need to do, right? Let me look at it real quick. If it is, define an appropriate geometric random variable. So the geometric random variable would be that she wins money. So how many times it takes her to win money is what we'd be looking at. So each trial, so. All right, so it would just be how long it takes her to play until she wins with a probability of 0.259. Okay, and then 115, you asked about that one as well. So we have a situation. This fast food restaurant runs a promotion in which certain food items come with game pieces according to the restaurant. So the probability of winning is 1 in 4. Okay, so if Jeff keeps playing until he wins a prize, what is the probability that he has to play the game exactly 5 times? So he's playing until he wins, right? So we're going to have failure, failure, failure until he wins. And this is just in general I'm talking about. So that first thing, if Jeff keeps playing until he wins, then it says, what is the probability that he has to play the game exactly 5 times? So we're going to have fail, 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 win. Now we could look at our formula sheet and you're going to see geometric, but the other option is just to take our probabilities of winning, which are 25%, right, because 1 in 4 wins. So he has a 75% chance of failing and a 25% chance of winning. So just lining those up, right? But these are independent events because, let me just double check that it's independent, but yeah, it looks like it's independent. Yeah, so just because he got a game-winning piece in one food item that he bought has no effect on the probability that he's going to get it again. So we're assuming that this is independent here, which means that we can just say fail and fail and fail and fail and win. So we don't have to worry about given that he won the first time. So he's going to have to fail 4 times. 0.75 times 0.75 times 0.75 times 0.75 times 0.25. And let me know if you have any other questions or if this did not help.